Hi everyone, my name is Andrian Kravchenko and I'm happy to present the work that was done together with Yurii, Paniv and Nazarii Drushchak, and the title of this work is UAlign, LLM alignment benchmark for the Ukrainian language. Before we proceed, I would like to express my gratitude to the talents of a Ukrainian project of Kyiv School of Economics for the computational research grant, and also to the Langfuse organization for offering a pro subscription that enabled efficient experiments monitoring. The plan for today is the following: background and motivation, related works, benchmark development process, experiments overview, limitations of this work, and intended use. First, I would like to explain a little bit of terminology. So the AI alignment is a process of ensuring that AI systems produce outputs that are in line with human values, and LLM alignment extends this definition a little bit, but ensuring that the model's responses are not only accurate and coherent, but also safe, ethical, and desirable from the perspective of developers and users. The key motivation for this research was LLM's rapid advancement, as nowadays they exhibit near human proficiency across different domains. Also, new models, more advanced models, are released every week. And this led to widespread adoptions and, more importantly, ongoing discussions about integrating LLMs into education and healthcare system that underscores the importance of alignment. Our comprehensive review of the related works revealed that LLM alignment evaluation usually spans 5 distinct domains: factuality, ethics, toxicity, stereotypes and bias, and general evaluation. There exists more than 30 benchmarks available for this purpose, but they are predominantly focused on English and Chinese. As for the Ukrainian datasets, there are extensions of holistic bias, and while they include Ukrainian in the technical report, unfortunately they are not publicly accessible. Also, there is AI evaluation suite that contains a subset with 200 examples in Ukrainian language, but they are of poor quality because of the translation via Google Translator. So we proposed the benchmark development methodology that we utilize in this work. It consists of several sequential steps. The first one is domain selection, the next one is the dataset selection, then applying the filtration procedures, and finally adaptation pipeline that consists of machine translation and linguistic refinements. Our choice of domain selection was ethics domain based on 2 criteria. The first one is relatively short textual samples that enabled efficient adaptation. And the second one is its challenging nature because it requires understanding of social norms and moral principles. From this domain, we selected 2 datasets, ethics and social chemistry 101, because of their exhaustive samplings. And another point is that they underwent rigorous human evaluation to ensure the data quality. Some key points about the ethic datasets: it contains over 100,000 examples of clear, unambiguous scenarios. It also covers 5 distinct ethical domains, and each example has a label as morally acceptable or morally unacceptable. During our filtration process, we selected common sense domain because it contained generalized ethical scenarios, and also it was the only domain that underwent cross-culture annotations. From the test set, we selected 1,700 shorter samples to enable efficient translation and adaptation. And the resulting subset preserved near equitable distribution among labels. Moving on to Social Chemistry 101, it contains over 100,000 real-life scenarios and is structured around the concept called rule of thumb, which is ethical judgment in natural language. And it has almost 300,000 of these annotations and is based on 5 moral foundations. From the annotation fields, we focused on the numerical interpretation of this rule of thumb and also on the inter-annotator agreement score. So the filtration process of these datasets consists of the next step. First, we selected the samples with the highest inter-annotator agreement. Then we filtered the samples by care-harm moral foundation, applied the duplication, and mapped a 5-point scale to 3-point scale for simplicity. This resulted in 3,682 samples with pretty balanced class distribution. The next stage is adaptation pipeline, starting with machine translation. For this purpose, we initially selected Dragoman models, as it has a SOTA score on the Flores 101 English-Ukrainian subset, but we found it insufficient upon our rigorous evaluation. So we moved on to the DeepL, and while it improved the translation quality, we still saw there a room for improvement. So we decided to analyze another LLM-based approaches and identified Claude 3.7 as the most promising alternative. To make our final choice, we performed internal human assessment comparing 100 random samples from each subset. You can see the results on this chart, and we proceeded with Claude 3.7. Also, we wanted to ensure that the adaptation quality is as high as possible, and therefore we decided to explore the further linguistic refinements. For this purpose, we utilized SpeedAuthor model that was trained on 4 objectives: paraphrasing, text simplification, coherence improvements, and grammatical error corrections. We tested 3 of them, and as you can see in the table, paraphrasing and coherent improvements can introduce new words or even errors which were not suitable for us, so we proceeded only with GEC. We also analyzed the changes of the GEC improvements by breaking them into 4 categories as unchanged, first letter capitalization and imputation adjustments, and sentence structure changes. Surprisingly, 92% of all samples remained unchanged. So moving on to the experiments, in our model selection, we prioritized open source LLMs with varying degrees of Ukrainian language support. So we selected models from iModels family, iExpanse, i101, also some general multilingual models like Llama 3.2, Gemma 2, Qwen 2.5, and we included GPT-4o as the proprietary model for comparison. As for the evaluation metrics, we employed standard classification metrics with F1 macro as a primary metric for comparison. Here you can see the results of the evaluation on the ethics subsets. Most models perform better on English than Ukrainian, with GPT-4o having the highest score, and among open source models, Gemma 2 it has the closest score to GPT. As for the social chemistry 101, the difference between Ukrainian and English are much smaller than in the ethics. Several models also perform better on Ukrainian, and here Gemma 2 demonstrates better performance even than GPT-4o. We also observed several model behaving patterns during our experiments. The first one is that Llama 3.2 had a strict alignment regarding suicide-related topics and refused to engage even for classification purposes. And also Qwen 2.2 struggled with output formatting, leading to failed generations. We acknowledge the following limitations of our works. The first one is their translation quality, as the machine translations are still not comparable to the human translations. Also the culture scope, since the datasets utilized were primarily designed for North America. Representation constraints, as we included only subcategories of ethical scenarios, and methodological limitations, since the source datasets simplify complex moral reasoning into predefined categories. And we identify the following purposes of this benchmark. The first one is direct evaluation of LLM alignment in Ukrainian language. The second one is cross-lingual studies on alignment. And the third one is further research on cultural differences in moral evaluations. On the right part of the slide, you can see the QR code that will lead to the published dataset on the Hugging Face. Thank you for your time.